Um, hey there. I thought it might be a good idea for me to just put a quick video together explaining 6.1 through 6.3. And I'm going to post this Monday afternoon, probably around 2-ish or so, because these were kind of difficult. All right. So let's talk through them. I've already received them from a couple of you, so I really appreciate the effort that's put in there. Please know I'm just going to be grading this on effort. And I really do need to get on grading. So you'll start to see some grades come in, all based on effort. Okay, that's it at this point. So as long as you tried, you're going to get a 3. All right, so back to this. So 6.1a, I just gave you the data for that. So we're all using the same data. For B and C, let me scroll down here. All right, I used the Desmos graphing calculator, and all I did was I typed in a table with the data from the points, and this is what mine looked like. And then I was trying to fit an arrow over that, and I could not do it. So I thought, well, you know what? I'm going to need to probably have the formula anyway to do these other questions, and sure enough, I did. So I just decided to use the slope-intercept form, and then I chose 2 points that were on the line that I thought would make a line of best fit. I will tell you my line differed from the book. I'm not going to give you the book's line yet, but it doesn't matter. I expect that everyone's line might be a little bit different. So I chose the points 84, 13.1, and 120, 17.3 to determine my line. So I found my slope was 0.1167. So I did delta y over delta x for that. And then my y-intercept was 3.3. I found that by actually plugging in the 84 and 13.1 into the formula and then solving for B. But you can also see that from the graph too. So I probably could have estimated that one as well. Either way is fine. These are just approximate. Later I'll talk to you about putting like a little cursor over the y, which means it's approximate. We're not going to get into that yet though. To come, material to come. Okay, so for letter D, what does the slope represent and what does the y-intercept represent? So the slope represents the increase in the field of view for each inch the viewer moves away from the wall. So remember, the slope is what happens every time x increases by 1. So in this case, the x is the distance from the wall. So in my case, the field of view increases by 0.1167 inches every time the viewer moves 1 inch away. The y-intercept represents the field of view in inches at a distance of 0 inches, right? So even though a person is 0 inches from the wall, they can still see something, all right? So partly because there is the length of the tube, all right? Weird but true. All right, so for 6.2, basically, it took me a while to do some of the conversions and that type of thing. So I wanted to share this with you because no matter what your equation is, these conversions will be the same. All right, so for the south end of the field, it's 50 yards from the pipe, but my equation is in inches. So I had to convert it to inches. So since there are 36 inches in a yard, I just did 50 times 36. That gave me 1,800 inches. For the north end of the field, it's 170 yards. That would be the same for you. So it's 50, that's from the pipe to the edge of the field, 10 and 10 for the end zones, and then 100 for the field, so 120 altogether. So 170 times 36 is 6,120 inches. So then the next thing I did was I used my equation, and then for the south end, I plugged in this 1,800, and then for the north end, I plugged in the 6,120. I got 213.36 inches for the south end. I got 717.504 inches for the north. For both of them, I divided by 36 to get the yards. So you can see my the number of yards I can see at the south end are 5.937 yards, and then at the north end, 19.93 yards. All right, so then I have a printer. So I was able to just put this right on the sketch. Don't worry about that. You could even just do this purple piece, the trapezoid, and just label the dimensions at the top and the bottom. You do know that the length of the field is 100. Well, actually, it's going to be 120 because you have both of the end zones. So you know that the length of the field is 120. So you can just draw out the trapezoid. You don't have to draw the whole field out. Okay, then to figure out the area of that, I use the trapezoid formula. And here's the formula for the area of a trapezoid right here. The area is 1/2 the height times basically the sum of the bases. The 5.94 and the 19.93 are the bases, so I've added them together right here. So then I did half of 120 is 60, and then when I added these I had 25.87. So my area is 1,552.2 yards squared. Yours should be something similar to that. And the nice thing here is I didn't have to do any conversions because I already had it in yards. All right, then the next thing, all right, so for A, I wrote the area. Okay, then the next thing, the percent that Robbie will be able to see. Well, I took my area here and divided it by the area of the entire field. To get that number, I did the basic area formula for a rectangle, right? Length times width. So 120 is the length and the width is 53.3. So I have 6,396 yards squared. And I did check this with the answer key just to make sure I did that right, and I did. So basically it's 1,552 divided by 6,396. I got 0.243, which is about 24.3%. So that's the percent he can see. For letter C, all right, this was the probability that Robbie can see a touchdown. So first thing I had to do was figure out, oh, that's going to be a different amount than the end of the field. So that's not going to be my 19 something yard figure. So first thing I did was figure that. So I had to take 10 yards off. So I did 160 times 36. So you would have to take 10 yards off too. So you would do the same, 5,760 inches. Put that into your formula. When I put it into mine, I saw that Robbie could see 675.5 inches, and then I converted that back into yards. It's the same calculation as I did before. I've just got this as 160. All right, so then I saw that for the north goal line, he would see 18.763 yards. All right, so then, since the entire length of that is 53.3, and you can cross anywhere along that line for a touchdown, I just did 18.763 divided by 53.3, which is 0.352, 35.2%. That's the portion of the line that he can see. So then the probability of Robbie being able to see a touchdown is 35.2%. All right, so I'm hoping this helps a little bit. These are some kind of, I think the word I want is tedious. These are some tedious calculations. So I'm giving another day to do this. Hopefully that'll kind of ease up a little bit on some stress. I'm going to post this right now. It's about 2 p.m. on Monday, and that should give you even a little bit more information to go on to get this assignment done. Hey, thank you, everybody. Email me with specific questions if you've got them.